Welcome to episode 348 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
All right, Rob, how are you doing?
Doing good. Had a chance to go by a conference the other day, I heard?
Well, yeah, so I'm not speaking at C++ now, but I took a couple of hitchhikers from Denver International Airport up to Aspen and hung out for one night and crashed the opening ceremonies and gave away a few puzzle books, and it was fun.
Nice. Very nice. And the conference is going on, like Monday to Thursday this week? Something like that?
Monday or Thursday or Friday. I think they usually have a half day on Friday. I don't know. I didn't look at the schedule. It's something like that. Okay. And of course, it snowed on the first day because that's what it does in Aspen when we're in C++ now for May. Yeah. Although they didn't it wasn't sticking on the ground in Aspen, but on my way back as I was coming near Vail Pass, for people who know the area, it was like a picture book, like winter wonderland painting. All of the pine trees were heavy laden with several inches of fresh, heavy spring snow. And it was made for a pleasant drive, except I kept getting a little nervous that I might hit icy patches on the highway.
Yeah,
but
it's not fun.
Yeah, but it had been warm enough and enough cars on the road that there was no actual ice. It was fine.
Very cool. All right. Well, at the top of every episode, I like to read a piece of feedback. We got this from Christabella, actually asking us to promote this tweet he sent out saying, got a moment to say how Clang's diagnostics can be improved. Our team wants to address users' biggest pain points with Clang's diagnostics, and your feedback directly help us figure out what these are. Compilers should be helpful, not combative. And there's a link in here to a Google form doc where they're looking for feedback, Chris's team, on improving Clang diagnostics. So it definitely seems like something that would be interesting to a lot of our listeners, and I'll put this link right at the top of the show notes.
That's pretty cool. I mean, Clang pretty much already has the best diagnostics at the moment, I think. I mean, GCC, they're pretty close, but always good to see better reporting.
Yeah, definitely. All right. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Joel de Guzman. Joel got into electronics and programming in the 80s because almost everything in music, his first love, is becoming electronic and digital. Back then, he used to build his own guitars, effect boxes, and synths. He enjoys playing distortion lane rock guitar, composes and produces his own music in his home studio. Joel's the main author of the Boost.Spirit parser library, the Boost Fusion library, and the Boost Phoenix library. He's been a professional sound software architect and engineer since 1987. Joel specializes in high-quality cross-platform libraries, particularly, but not limited to, those written in C and C++. Joel is an expert practitioner of modern C++ techniques, template metaprogramming, and functional programming, with a focus on generic programming and library-centric design. Joel, welcome to the show.
Hi. Nice to be here.
Thanks for coming on. So, when I was just in Aspen yesterday talking to a mutual friend, he told me that I had to ask you about how you specifically got into programming. Like, what was the thing that drew you into programming to start with?
Oh, okay. So I started doing electronics. So I think that short biography kind of gives you a hint on how it started. So my father was an EE, electrical engineer, and I got amazed with what he's doing, and he's doing really cool stuff back then. So I started with analog electronics actually, and so I got interested with doing effects, distortion, and all that kind of stuff. And then the 80s came, and this shift towards analog to digital started to happen in the 80s. So, okay, I've got to learn this thing. So that's how I started when I started doing C++. So before it was Pascal. So it was nice, but then later in the 90s, I moved on to C++.
And that's specifically for like making guitar pedals? Is that what you're saying?
Oh no. Okay. So in the 90s, the most of the 90s, I went to Japan.
Okay.
I worked there as an engineer. So we did kind of cool stuff, like we started doing the graphical user interfaces and a whole operating environment on top of operating systems. So that includes the whole thing for rapid application development. And so that was a huge endeavor at the time. So it took us a lot of time in doing that. And so we got funding from for doing research from the Japanese government at the time.
Okay.
Oh wow.
So that was the time when I actually started writing graphical user interfaces and got involved with more in depth into C++. So that's the time when I got into open source. I got interested with open source. So I remember meeting up with Michael Tiemann. So he's one of the originals G++ authors,
Okay.
if I remember correctly, and he's now he's I'm not sure what he's doing now, but he was with Red Hat, one of the VPs, I guess. I'm not sure about the details though. And I've got to meet some cool people over the internet through like Andre Alexandrescu. So we corresponded a bit through email. And so I got hooked into this template metaprogramming thing. That was before what you call the dark ages of C++, you know. So that was a time where things didn't really work the way they're supposed to work. We didn't have the features that we have now, we take for granted now. So we have to do all those we have to work around all those things at the time, and we have to contend with lots and lots of internal compiler errors and incompatibilities with different compilers, especially MSVC, which was the most difficult compiler I had to deal with at the time.
Right.
All right. Well, Joel, we'll get more into your bio and some of the work you've done in open source in just a few minutes, I think. But we do have a couple news articles to talk about, so feel free to comment on any of these, okay?
Okay.
Okay, so this first one is a post on Red Hat developer blog, and this is new C++ features in GCC 12, which looks like it's coming out or did come out April 2022. Yeah, and lots of new features in here. Some C++ 23 features coming out in this, like if const eval. Or am I reading that wrong? No, that's C++ 17 was if const expert, const eval is C++ 23, right?
Yes.
What else do you want to highlight in here, either of you? Anything exciting?
The main thing that stands out to me personally is the possibility that they elide standard move, standard forward, address of, and as const, even in debug builds, because this is something I brought up in a talk several years ago, And Quarantine, I know, was working on doing this kind of elision of these calls and debug builds in Clang, I think. I don't recall if Quarantine was involved in the GCC version or not, if I have that story backward. But if you, in a debug build, it's kind of ridiculous to see effectively casts inserted into your code. So you have function calls that are just casts, but they have the ability to elide them now in debug builds. I find that interesting.
Nice. How about you, Joel? Anything you wanted to call out in here?
Well, I got to read some of the stuff, so I'm interested with multiple arguments for the array subscript operator.
Right.
So that I got interested with that, particularly because I used to overload over the comma operator a lot.
Right.
Oh, okay.
For DSELs,
Right, for that kind of use case specifically, right? Apparently, even though it's supposed to be illegal as of C++ 23 to use comma operator inside of the subscript call, GCC does specifically say that if they detect that there's a comma operator overload, they will still allow it and emit a warning instead of going to the multi-argument subscript operator.
Oh, okay.
And there's an aspect of this that I actually recorded a C++ Weekly episode on this, but an aspect of it that I had never considered, that means that you could have multiple subscript operator overloads. You could have one that takes 1 argument, 2 arguments, 3 arguments, if you were so inclined.
That's
I don't
cool.
really know what the full use case is, but yeah.
You'll never know, right? So.
All right. Next thing, we have another ISO mailing. This is for April 2022. Not the biggest one, but I'm recognizing plenty of the papers in here. We obviously were just talking about the linear algebra libraries and MD-Array, MD-Span last week. Those are all getting updates in this. There's also an update to Embed, Jean-Yves Manid's paper.
Release 5 of that one.
Yeah, I didn't check to see what was actually different in it, but I'm glad to see it's still being updated, still being worked on.
Yeah, I also didn't read it.
Anything either of you want to highlight in this?
I think it's kind of, I don't know, maybe slightly humorous or something to just point out that Victor's updates to format are now at revision 14. I don't know when that paper will finally fully get accepted and merged. I think it's, to give things like format : print instead of having to do C out of a formatted string or whatever. There's another one in here. Oh yeah. First revision of a paper to give a description to equals delete. So if you explicitly delete an overload, to be able to describe why, so that the user of your library knows, hey, you called a deleted function. This is the one you should call instead. This is why this was an error.
It's cool.
Makes sense.
I don't know if the syntax is going to fly, though, just looking at it myself, but I'm not in evolution, so.
All right, and then last thing we have is a couple call for papers for upcoming conferences. This first one is for Core C++ 2022. That conference is going to be in September, and the call for speakers deadline is June 15th.
So when this airs, you will have right at a month.
Yeah, just about a month. And then we also have one for NDC Tech Town. And this one has a deadline May 1st. Oh
no. That's my fault. I put it in there. So yes, the deadline is already passed. I didn't submit a talk. I debated it. It's too late now.
Guess so. Okay. Well, So, Joel, we were already talking a little bit about how you first got involved with C++. Could you maybe tell us about how you got involved in the Boost community?
Boost. Okay. So after Japan, we went back home, but that meeting with Michael Chiman got me thinking about open source. So I I know that um, you can build a career on open source at the time, but I couldn't explain that to my boss. So
Hmm.
there's no way for me to articulate how that'll work. So how will you uh, how will that happen if you give your software for free? So that's the basic question there. But I still I still got thinking about open source, and I was still um um emailing and joining the news groups and the C++ news groups at that time. So, and there's when I got involved with Boost. So I was thinking, maybe I could take a portion of the library that we created in the 90s, uh, um, and rewrite that using uh, um, um, what we called at the time the modern C++, which was coined by Andre.
Right.
Mhm.
So it's not the modern C++ that we know now, with the features that
Sure.
we have now, that we take for granted, you know. Um, um, so that's a time when I thought, okay, so a part of the framework that we wrote was the parser library, and so I wrote that part using template metaprogramming, and that became Boost Spirit. So that's how I got involved into Boost. So there were lots of interest when I introduced Boost Spirit into Boost, and um, it got accepted, and I, I there was an article at the time for I wrote along with Don Nuffer. Uh, that was not C++. No, that's Dr. Dobbs, if you remember this
Hmm.
magazine at the time. So the C++ report was a big thing at the time. And so I got to, these were the source of information for current C++ at the time. And so we wrote an article about Spirit, which kind of catapulted it to the C++ community at the time. And then it got accepted into Boost. And that's how it started.
When I'm just out of curiosity, when approximately was that Spirit was added?
Oh, okay. 2001.
Okay.
So I got involved with Boost. So initially I was in lurk mode. So that was in the late 90s when I was still in Japan. So I was following what's happening. There was Dave Abrahams and Beeman Dose, and um and then I got to introduce Boost Spirit out of nowhere. So and so people got interested with what I was doing. So
So are you still involved in the maintenance of Spirit today?
well, there's a lot of things to do. So I have lots of libraries. So someone else is maintaining it for me.
Okay.
Um, um, but I'm still involved with reviewing pull requests
Hmm.
and stuff like that, and being taking part in the conversation. but I wish I had more time than I have right now to do more on the Boost libraries that I authored.
That's a long history, 20 some odd years to still
Yeah.
be involved on it. I can't do that. I give up after 10 years or so.
Well, I guess let's talk a little bit about a newer library you're working on that a listener suggested we talk to you about, and that's Elements. Can you tell us about Elements?
Oh, right. Okay. So around to 2016, I was looking for graphical user interface library that I need to write GUIs for an audio plugin set of audio plugin software that I've been writing for for the projects that I'm involved with. But for a long time, I was searching for the library that I was looking for, but nothing really clicked.
Mhm.
So I thought that it might be a good idea to modernize the concepts that of the graphical user interface libraries that I wrote in the 90s and modernized into C++ 17 at least at the time. So
Mhm.
that was 2016. And so that became Elements. So, well, it has to be modern C++. So I'm a proponent of modern C++. So none of the 90s style virtual, class virtual functions and all that stuff. But I still
Mhm.
do that though, but not in the way that there's a modern twist with it. And so it
Right.
has to be lightweight and modular. And I think the main thing that really necessitated me to write this library is that first it must have a liberal license,
Mhm.
non-viral. I don't like viral licenses, and um, that only that leaves me with only one option at a time, which was juice.
Okay.
But but that was that it has the uh, viral license, and so that's out of the question. So that's why I started Elements. So it has to be modular because it has to um, s- this the library that I need cannot have control over the event loop, for example,
Oh, okay.
because
Cannot. Okay.
it has to coexist with other libraries and frameworks.
Right. So you said audio plugins is what
Yes,
you're
audio
targeting.
plugins, exactly. So at the time, so the only option at the time for doing that was Boost and this thing called iPlug, but
Okay.
those are kind of monolithic things, um, and I'm not really quite happy with the way C++ was implemented, or how everything is structured. So that's how it started. So when writing audio plugins, you don't even have control over creating the window yourself.
Hmm.
Most of the
Hmm.
time you'll be given a handle to the window, and you draw your interfaces and with that. So that's the modular part of the Elements element, and so it has to coexist as it is, and be able to be transplanted into other frameworks and libraries and the operating system.
So just out of curiosity, you said not having a viral license was very important to you. What license did you end up choosing for Elements?
MIT.
Okay.
But I think I'm gonna switch back to Boost license.
Okay. And you said you've been working on it since 2016, and the screenshots you have on the GitHub page do look really beautiful. So it sounds like the library's come along a long way. Do you know is anyone like using it in production?
Elements. I only implement what I need
Okay.
for my specific use cases. So I've been working on it on and off, and there are other contributors and working on it implementing other features. So I'm gonna take this opportunity. So it'll be great if I get help from other people who's interested with writing graphically user interface widgets and all this stuff. There's
Right.
still a lot of things that needs to be done. Um, it's not even I'm not even considering it to be 1.0 at this
Okay.
point, but I'm already using it in the applications and plugins that I've been writing, and other people are using it for other people uses for other plugin libraries. I guess, and some more applications here and there, but I think I don't know yet of any big application that's using it at this point. So there, it's kind of still new. Although I wrote it in 2016, um, I only officially introduced it in, I think, 2019.
Okay.
So that was that already involved um, lots of evolution from the original implementation, and
Right.
that's where artists came in. So at one point, I thought it's a good idea to separate the graphics part of the library into its own, and target um, graph 2D libraries like Skia.
Oh, okay.
So and uh, make it more suitable for more higher performance applications. So graphical user interface applications. And so and recently there's been I've been having help from Benjamin Aldenberg. He's doing metal on Mac and
Oh, that's cool.
D3D on Windows. And I know you'll be asking about package support, so he's also
Mhm.
working on VC package. And
Okay.
so
You mentioned at the start of the description that you were trying to avoid things like virtual in the design, if I heard you right. And GUI frameworks is like a classical use case for virtual because you've got your button widget, your slider widget. They
yes,
both need a draw method. They need a whatever. So I'm curious, did you manage to avoid virtual in those
no,
cases? Okay.
no. It's not that I'm avoiding virtual. It's just that I'm trying not to think of the abstract class using virtual functions as the one and only means for writing graphical user interfaces,
Okay.
graphing writing classes for widgets and all that stuff. And so you can at some point manage to do it without virtual functions and have the declarative. Okay, so well, one of the design objectives of Elements is that it has to have a declarative API using modern C++. So I'm a proponent of declarative C++. And declarative C++ essentially tells you, the code tells you what rather than how, imperative. So the GUI is actually declared in C++ code instead of having an external code generator
Okay.
or
Mhm.
graphical interface builder to build it. So everything is self-contained in the C++ code. So I really like that because I have control over everything in C++. And so at some point with declarative C++, where everything is defined declaratively, you are able to use more of the modern C++ mechanisms instead of classes and virtual functions. So I basically I have a mix of the two
Okay.
worlds. I still need virtual functions and type erasure in general to store widgets into vectors and
Hmm.
um, but for a large portion of the how you're using the library, you're able to capture the essence of the structure of um, the elements composition without having to go to virtual functions, without
Okay.
having to use um, this kind of stuff.
So you can actually have a compile time representation of the GUI interface without having to call virtual functions necessarily. But if you,
Yes,
okay.
exactly. Yes, or at the very least, the compiler will give you the freedom to choose which ones you want to have um, as dynamic, and which
Hmm.
ones want to have as a static. With the static parts, you'll have highly optimized um,
Right.
part of the graphical user interface. Not that it's needed, right? Because um, with graphical user interfaces, you the bottleneck is of course the screen.
Right.
So it has to
Mhm.
be drawn on the screen, and so it's not like what you do with really high performance computing, for example, but it's there and it's tight and it's nice.
Well, it seems like with uh, that it's the kind of concepts that would go nicely with, like, I'm wearing my Garmin watch here, where if you know certain components on a small embedded platform with its user interface, certain components are compile time known static, then you can take advantage of it there. And in the small cases where the user needs to be able to drag a widget around on their watch, there could be dynamic use cases. So I could see those things working nicely in small platforms.
Right, yes. And one of the requirements is that it has to be simple and small. So I tend to um, avoid the temptation of having all the features crammed into the library.
Right.
Okay. I guess one thing I want to ask, you talked about how you're mostly using this to target audio plugins, but you can make your own like full GUI application with this library, right?
Oh, yes, absolutely, yes.
Okay. And
Uh,
what platforms does it support currently?
Currently, it supports Windows, Mac, and Linux.
Awesome.
That covers most devices.
Yeah.
Although
Well, I still have to look into iOS and Android. So that's one thing that I really want to get into. Maybe it's I don't have actual need for it right now, but
Right.
some people do, and if you're one of that, so it's open source, so you're welcome to contribute to the code. I invite people.
sorry, didn't mean to interrupt.
It's okay.
Another thing that caught my attention was you said in the audio plugin world, sometimes you're simply given just a handle to a window, and that's
Yes.
what you have to draw into. Does that mean that the way I'm envisioning this, you must have had to have designed it to be very portable to be able to say, well, here's some pixel array that you have to work with. Now go do your job or something like that.
Yes, exactly. So um, there are only a couple of files that needs to be implemented to be. It's very portable.
Okay.
So only a handful of files that needs to be implemented to have it running on other platforms. In fact, it's not just other platforms. For example, it's very doable to have it transplanted into, for example, Qt
Okay.
Oh, okay.
So if you had a
or
canvas and Qt,
or
you could.
other. Yes, exactly. So other anything that given a handle to a view, a window, a sub window, you can draw into. You can have elements running there, so
Okay.
it can run on top of traditional and graphical user interfaces, for example.
Sounds like then porting to WebAssembly or Emscripten or whatever should also be pretty easy because then you can just draw into an HTML canvas.
Oh,
Yeah.
that
Also,
too. So, oh, well, one the art that the artist, the graphical, the 2D graphics part was inspired by um, the HTML5 canvas actually.
Oh, that's the
So
artist
I in
library you're referring
the
to?
artist library, yes.
Okay.
So I implemented that on. So it's not so thin abstraction layer on top of um, um, Quartz 2D and Skia and Cairo.
Okay.
So there's that layer, and then the abstraction of that is that the interface is more like the W3C canvas.
okay.
Well, there's been a couple of times that I thought, it'd be cool to make an interface that was just drawn with like all SVG elements or all like vector-based elements. And then I found myself looking at like the Cairo API and saying, never mind. So if you've given like
Yes.
a C++ higher level view of being able to do this kind of scalable graphics, is that what you're saying?
Yes. So essentially, it's an superset of the W3C canvas interface
Okay.
with a modern C++ twist. So I didn't like aesthetics, like instead of camel case I have um, um, you know lowercase and underscores,
Okay.
things like that.
And so how are artist and elements directly related to each other at all?
uh
Are they
what
completely
could,
independent
could you explain
projects?
it? Those are independent projects,
Okay.
so they have their own GitHub repository,
Okay.
and artist is independent from elements, but elements depends uses our artist as the 2D drawing
Oh,
layer.
okay.
Oh,
So
okay. Okay.
that's the layering there. So
So if I just want to draw some high resolution vector graphics, I can grab artist and render that to some frame buffer of some sort.
absolutely, yes.
And like full alpha channel support, all the normal things that you would need for this kind of thing.
Absolutely. Yep.
That sounds pretty cool. I might have to play with that. It looks like it's gotten less visibility than Elements so far. Not quite as many people contributing and such at the moment. So maybe that'll get some visibility as well.
Oh yeah, so I love that. So well it's the thing is that elements started um before I decoupled the graphics part.
I see.
So it was a monolithic. The artist and elements was one, and so around 2020, pandemic, if I remember correct, that's when I started decoupling the graphics part from elements, and that became artist. And that's also the time when before it was just Cairo, and I was kind of worried because I'm not sure what's happening with Cairo at the time, and it, I'm not sure about the future of Cairo.
Mhm.
And so I thought it's a good idea to also decouple the artist library from the underlying
Uh,
2D engine, so such that I can target, for example, on the Mac OS, you can have it running under Quartz 2D, and as well as Skia right now. So you can do that, and in Windows that's Skia, and Linux is Skia. But I'm considering backporting Cairo to Artist right now. The Artist doesn't have the Skia port. I'm sorry, the Artist doesn't have the Cairo port because of the API. Um, Cairo doesn't have modern features like being able to blur
ah,
images and stuff like that.
hmm.
So,
Interesting.
and more of the advanced features of Ski, um, Cairo doesn't have that. So Cairo is kind of old in terms of features.
So all of this work is under a GitHub organization called CppCast, or I don't know how to pronounce that.
Oh, okay. So it's pronounced sci-fi. So
CppCast. Okay.
it's the cycle of fifths. So that's how it that got into becoming sci-fi.
Okay, so I went to CppCast's website. This is your company? It is? Okay.
Yes, it is. Sorry.
It looks like you're doing all kinds of crazy, like guitar pickups, hardware, hacking, audio things that I feel like a lot of our listeners would be interested in if you want to just brag about your company for a few minutes, please do that.
Okay. Well, Sci-Fi was my baby from 2014. My main work from at the time, I was consulting for Kiara, Michael Casey,
Mhm.
and before that, that is Boost Consulting. So I've been doing C++ consulting for well 2 decades now,
Wow.
and so um, that's still my main preferred line of work.
Okay.
But recently, things evolved, and sci-fi is kind of taking off. So with that, I'm still able to apply my love for C++ in doing this, as Jason says, some crazy stuff. So we've been doing, uh, I've been doing multi-channel processing, where if you see that guitar behind me, that's
The one in the middle, the black one there?
the middle one. Yes,
Okay.
that's made out of carbon fiber,
Oh wow.
Okay.
and there's microcontroller inside that, and it's running using modern C++, and it's doing multi-channel processing. So it's processing each of the strings individually. So the traditional way of doing it is that you have your guitar; it's a monophonic instrument,
hmm
and you have your effects line. You have a line of effects from distortion, compressors, and all that stuff. So you have that mono signal going through all those effects. But what we do is multi-channel processing, such that each of the strings can have its own stream of effects.
Oh wow.
So we have, for example, with that sixth string there, you have 6 streams of effects, 6 streams of digital signal processing going on at the same time. And what's interesting with that guitar is that it has multi-channel sustain,
Okay.
so you can form chords and it won't die out. It'll sustain as long as you hold the chord.
Okay.
So there's a feedback loop with a magnetic transducer that's sensing each of the strings and balancing out the levels of each of the strings, such that it'll sustain as long as you want it to sustain. And then after that, there's a stream of processors going on for each of the channels. So that one is doing the multi-channel sustain, and then you get, instead of the monophonic jack that you plug into an amplifier,
hmm
I connect that to an audio interface, multi-channel audio interface, with all of the 6 channels. It's capable up to 12 channels of audio. The interface is capable of
Wow.
that, and then with software, if with a digital audio workstation, you can set up multiple effects for each of the channels individually, so you have really awesome control over that. You can you
Sounds like
can
you
do
can.
lots of cool processing there.
It sounds like you'd be capable of making, some very unique music that you just could not have with a normal guitar plugged into an amp with this, right?
Absolutely, yes.
Very cool.
So is it possible for someone to just go to your website and buy one of these multi-channel pickups and retrofit their current guitar with it?
Yes. So that the multi-channel pickup is can be retrofitted into a standard pickup slot, so it's the same footprint.
Okay. I think what I want to see personally, I mean, guitars are awesome. I don't play any musical instruments. I'm not inclined that way. But if someone were to take your multi-channel pickup and just make the world's most awesome input device for their computer, so they're like jamming on their guitar and instead like programming, typing on it. I mean, like, I don't know. Maybe someone will do that.
I'm not sure how that will work, but that's interesting.
I mean, you've got all the frets, you've got all of the strings. I mean, arguably, you've got like a 60 key keyboard, right? I mean,
Yeah, that too. Well, that's another thing though, because for to do that, you need to do pitch tracking.
right.
So you have to. That's one of the things that I've been involved with as well. Pitch detection. So
Okay.
it's difficult. Pitch detection is difficult. So um, e- especially low latency pitch detection. So it involves autocorrelation of the signals and determining the fundamental and being able to determine which is noise and which is not, and things like that, and being
Right.
able to detect the onsets of when you start picking.
Mm.
That's also difficult. So I thought it was a rabbit hole at the time when I thought, okay, I'll do I want to detect the pitch that's such that when I have the pitch, I have the pitch information. I can do lots of really cool stuff with that. So
Right.
you know that you have a G2 or G3 or E5, you know,
Right.
and so being able to determine the pitch, you can do lots of cool processing, but easy said than done. so so it's still an ongoing process, but I do have really cool algorithms for detecting pitch and detecting the onsets.
Very cool. All right. Well, Joel, is there anything else you want to plug before we let you go, or anything we didn't ask you about elements or artists that you want to tell us about before we let you go?
Yeah, so as I mentioned, I probably just reinforce that, reiterate that it's our elements, it's not yet 1.0. So and I need your help to have that into a state that can be production ready.
Mm-hmm.
And I've been involved with Boost for a long time, and the interaction with the Boost community was awesome. But after Boost, and that Elements is not part of Boost, I'm not sure if it's suitable for Boost in the first place. I'm not sure about that. If there's interest, I'm not sure. But I crave for that kind of interaction
Mm-hmm.
that I'm not getting right now outside of Boost. So I will welcome anyone who's interested with have a look at the library, have a look at the GitHub pages, the introduction, and um, the examples. Try to run the examples, and if you find it interesting, I'm very welcome to um, have you be part and contribute into the code.
All right.
Well, yeah,
I expect
definitely
a few people.
encourage
Yeah.
our listeners to go check it out. Like I said, it's a beautiful library, and it's good to see that it's all you're interested in having more contributors. Yeah. All right, Joel, thank you so much for coming on the show today.
Thank you, and thank you for having me.
Yeah, thanks a lot.